Okay, first we're going to explain series resistance. We have three resistors in series, 100 ohm, 50 and 10 ohms, connected to a battery. We can compare resistance to a water system with pipes. Like for example, a 10 ohm pipe is going to be this big. A 50 ohm pipe is going to be 5 times smaller than the 10 ohms. And the 100 ohm pipe is half the size of a 50 ohm. So the higher the number, the smaller the opening for the water to get in. So here we see 100 ohms is this small, 50 ohms is double the size, and 10 ohms is 5 times bigger than the 50 one. So we see that the water, here we have unlimited amounts of water can come in, and it has come out, unlimited amount of water can come out. But we see that the restriction depends on the highest resistance. The highest resistance has the smallest diameter. The lowest resistance, where it's less resistance, where the water can go easier, so the pipe is going to be bigger and it's going to be easier for the water to flow through. So we can see that the current through the whole system depends on the highest resistance, because the water is going to be, the amount of water that can pass through cannot be more than the smallest resistance. So whatever can come in here is going to come through here, and it's going to come through here. The same amount of water is going to come out. But this is the amount of water that comes out here. The same amount comes out here, and the same amount comes out here. No matter how big the pipe is, it's going to be depending on this one here, on the smallest one. Same thing here. If we switch position of the two resistors, now the smallest pipe is going to be in the middle. We have a lot of water coming in here, but here it's going to be reduced to only half, and again we're going to have only that much coming out. So we can see that the current, which similar to what you can compare to water, it depends on the highest resistance. The highest resistance is going to limit the current through everything. And it's going to be the same current, you see the same current through the whole circuit. Current in every resistor is the same. If you have, for example, 1 amp going through here, 1 amp, it's going to be the same 1 amp here, and it's going to be 1 amp there. So the theory, if in series resistances, the current is the same in the whole circuit. Same current. If you can calculate the current of one, you know the current through all the other ones, because it's going to be the same. Only the voltage is going to be different. The voltage depends on the resistance, because the voltage is the pressure you're going to put here. Here you're going to have more pressure because it's a bigger pipe. You have more pressure than this one, and here you have the lowest pressure. So depending on the resistance, you're going to have different pressures or different voltages. So in series resistance, what you have to remember is that the current I1 equals I2 equals I3. Any current, whatever E1, 2, 3, 4, 5, they're all the same. It's the same as I total. As the total current coming out here, I total, there is no total because they're all the same, 1, 2, 3, 4. Only the voltages are different. Voltage 1 is 1, X, voltage 2, X, Y, voltage 3 is Z. The total voltage, this is the total voltage. The total voltage, you have to add up all the different voltages of 1, 2 and 3. Voltage 1 plus voltage 2 plus voltage 3 equals to the total voltage of the battery. So voltage 1 plus voltage 2 plus voltage 3 equal to total voltage. This is all you have to remember about series resistors. Now in parallel resistors, it's just the same but reverse. The voltages are the same and the currents, you have to add them up to have the total current. Now we have the same resistors in parallel, 10 ohms, 50 ohms and 100 ohms. And we compare again with the pipes. This is a 10 ohm pipe, 50 ohm pipe and 100 ohm pipe. The 50 ohm is double the size of the 100 ohm, and the 10 ohm is 10 times bigger than the 100 ohm. So when we have water coming in here, so we can see that a lot of water is going to go through here. Less water is going to come through here, and again less go through this one, and they come all back together here. So we can see that the current going through here is not the same as here, and it's here, it's different. So the total current that comes in here is this one plus this one plus this one, because they come all back together here. All this comes together here and it's all the same again. So the total current coming out, I total, is this current I1 plus I2 plus I3. And the voltage of the battery, like say we have 100 volts, we can see that the 100 volts, this point is the same as this point here, the same as this point here and here. This point, this side of the battery, is the same as this point over here, same here, here, here. So we can see that the 100 volts applies to this resistance, the same over here. So we have the same voltage on every resistor, we have the same voltage as what you have here. So the voltage is the same in every resistor. So the total voltage equals voltage 1 equals voltage 2 equals voltage 3, etc. The current, the total current, I total is the sum of all the currents. The current that comes in here plus this one plus this one. So total current is I1 plus I2 plus I3. This is I1 for example, and this is I2, this is I3. Doesn't matter what number you give. You just add up all the currents and you're going to have the total current. So it's just reverse of series circuits. That's all you have to remember about parallel and series circuits.